Hi, welcome to the session of singling linked lists. So we have already discussed about array as one of the key data structure. Array is a linear data structure. Similarly, linked list is also a linear data structure. And linked list is one of the very important concept. And when you are talking about single linked list, we will be moving into after that. Once you understand the concept of single linked list, we need to understand the concept of circular linked list and the doubly linked list. So let us understand first the linked list and then we'll move why we require the linked list, then its advantages and also about the disadvantages. So single linked list is nothing but a linear data structure. Okay. So in array, we have seen that the memory, if you are storing elements in the array, and in array we are storing the homogeneous data, right? If you are storing integer or other we are storing float, characters like that, right? So now having said this, elements that are stored in array in a contiguous manner. So integer 4 bytes, that is the reason why if the starting address is 2000, then we have 2004, then you have 2008, right? Okay. But in the case of linked list, elements are not stored in a contiguous memory location. If you see this diagram, like 10, it is stored in some memory location like 2000. So 20 may be stored in some memory location 5030, and 30 may be stored in some memory location at 2030, right? So in linked list, the entire the nodes, right, the elements are not stored in any kind of contiguous memory location. Now the question comes, how do I know that after 20 after 10 20? So that is also provided by the link. Okay, and the link is represented using the pointers, right, in C++. So we'll be using some pointers. So 10 will be having the address of 20, and 20 will be having the address of 30. So as a result, from 10 I can move to 20, and from 20 I can move to 30, even though they are not stored in the contiguous memory location, right? Whatever in C we don't have to do so because we know it is stored in contiguous memory location. So just if we know the index value of array is 0, so next starting in C, it's starting in C++ 0, right? So 1 2, so if it is 0, then after the next index it will be 1 and I can easily access it, right? Okay, so having said this, let's move on. So these are the links that I was talking about, right? Okay, so next, how we represent. So actually this particular thing, each of this where we'll be storing both the data and the address is called as nothing but node. So node will be having two parts. One, the data part, another is the pointer part. That what we call it nothing but the address of the next node, right? So now if I say this one particular node itself, so we'll have the data part which is 10, and similarly after that we'll be storing the address of whom, address of 20, because 10 is linking to 20. So here it will store 5030 as I was explaining before also. So having said this, so each of these nodes will be having two parts. One will contain the info or the data part, and another is the address. Okay, the address of the next node, and that will be represented by the pointer itself, right? Okay, so here we have this address storing the address. So that is why we have this particular link. Okay, so let us understand this memory location. It is the memory pool that we are talking about. So now we have a linked list having element 10, 20, and 30. That is the reason why now 10 has to link to 20, right? Because the list is something like that. After 10 we have 20, after 20 we have 30. So after 10 if we have 20, that means 10 should store the address of 20, and the address of 20 is 5030, right? So it is 5030. That means we have a link from 10 to 20. Now 20 will be storing the address of 30, which is nothing but 2030. So we have 2030, right? And similarly we have the link. Yes, so let me repeat again. If you, so 10 will be After 10 we have 20. So after 10 we have 20 means 10 should store the address of 20. Now what is the address of 20? The address of 20 is 5030. So I store 5030. That means I have a link from 10 to 20. Similarly, 20, after 20 we have 30. So after 20, since we have 30, so 20 should store the address of 30, which is 2030. So address 2030. Yes. So 20 is now linked into 30, right? So that's what the representation itself. Okay. And after 30, there is no element is there. So we will be representing by null. This is very important because we know that the terminating condition of the linked list is the null, right? So the last element will be always pointing to null. Okay. So, right, why linked list? So already array is an Indian data structure we have. So why we require the linked list, right? Now the thing is, we have seen that array size is fixed. So if we have an array like declare, I array 5, so we can have only 5 elements that can be stored in the array, right? So array size is 5. That is, we can insert at most 5 elements in the array. If there happens to be a 6 element, we cannot insert it. Okay? So it is a fix. It is a fixed size in array, but in linked list there is no fix. Okay, we can continue to insert the element provided the last element will be always be pointing to null. Yes, so that's what the first array was as a fixed size, but linked list we are not talking about the fixed size, right? So next, as array size is fixed, insertion and deletion is expensive. Okay, so how it happens? So we have, like, element 20, 10, 20, 30, 40, and 50. Now let us delete 30. So what will happen? So we get a space here. We get a space here, right? Now the thing is that I can insert this element in this particular location only, but that will actually disturb my what? The continuity of the list, because the list says after 10, 20, after 20, 30, 30, 40, 50, right? So the list is 10, 20, 40, 50. So if I want to insert something, I have to insert after the 50, but there is no space after 50, and this space is blank, right? Yes. So how will I going to do it, right? So what we need to do is that we need to actually shift 40, right? And here and create space here. Then again, I have to shift 50 and create a space. So next particular slide, I will be showing this. See, I want to delete 30. So it is a space that is coming up here. So it is a free space, right? Now, array is actually full. Array is full, but array is full, but actually there is a space between 20 and 40. It looks to be full, right? But there is a space between 20 and 40. Hence, we can shift 40 and then 50 to create a space at the end to insert the data. Like, so what I do, I have a space here, right? So I will be shifting 40, right? And I create a space now here. Yes. Similarly, I shift 50 and I create a space here, right? So I get the space. Now I can insert it. Again, I'm repeating. So now I get the space. This is deleted. 30 is deleted. So there is a space between 20 to 40. So I have to move 40 here, then 50 here. So then I get this space. So what I do, I shift 40. Yes. So I get a space is created here. Okay. Similarly, I shift 50. I get a space here, right? Okay. So now I can insert it. Now I'm giving an example of 5 elements. Think if you have 1,000 elements. Think if you have 10,000, 1 lakh, 1 million, right? And suppose I remove the first data. Then there will be, if it is 100 elements I have, the 99 shift operation will be there, because 20 will be shifted there, 40 will be shifted there, 50 will be shifted, like that, 99 shifts have to be there. Yes. So you can see it is very, very expensive, right? So as inserts and deletion is expensive, we are talking about linked list. So you can have an idea like that. Even application demands more on insertion and deletion, then we always go for linked list. And an application which demands that insertion and deletion will be less, but viewing of the element will be very, very high, then we'll always go for array, because in an array we can directly access the element through the index value, right? So it's very, very easy for us to access it, right? As a result, the performance also increases, right? Now, but if application demands a lot of insertion and deletion will happen, then array is not the solution. Then the solution is the linked list, right? Now, linked lists have some certain disadvantages. Okay, let us see this disadvantage. Okay, so random access is not allowed. See, you cannot access, if you want to access 30, then I have to start from 10, 20, and 30, right? In a discussion, I just forgot to mention one thing. There will be always a pointer called as or start, which will pointing to the first element of the linked list. Okay. Now if I have to access 30, I have to start from 10, then I have to move to 20 to 30. But if this is stored in an array, index is 0, 1, 2, 30, I can directly write a of 30. If this is an array represented by a, so a of 2 is equal to 30. So random access is not allowed. Okay, so I have to traverse. Next, extra space for pointer. So in array, I am only storing 10, 20, 30. But here, after 10, I am storing the address. Address also an integer value, right? So X space is required. Here also a space is required. So here a space. So extra space is required in order to store the address, okay, of the next node, right? Next is no locality of references. So when you talk about no locality of references, as I was telling you, one thing very important aspect is that, okay, right? Key, as I was giving you the memory location. If you can remember, if you go back, okay, you can remember that I was giving you this memory, right? So if you see here 20,000 somewhere, it is dispersed in this memory. So there is no. So today I was talking about 2000 or 5030. Tomorrow it may be 3000, right? When I am execute, right? But in an array, what is happening is that if I'm storing this in 2000, next will be in the 2004, right? So what is happening? I can easily access it. I know from 2000 to 2004 and all. But in a linked list, it is not the case, right? Right? So linked list doesn't guarantee anything related to the memory. Okay, where exactly 10 will be, where exactly 20 will be, where exactly 30 will be, and all. Yes, but when you talk about array, if 10 is stored in 2000, next 20 will be in 2004, provided it is an integer, right? Because of 4 byte itself. So that is the reason why, you know, English talks about, no locality of references. Locality of references is a very important concept in the programming itself, right? Okay, that helps in maintaining the, in the performance of the program itself, right? Okay, so that is one of the disadvantages of linked list. So advantage, when you talk about advantage, yes, whenever you're talking about an application with more insertion and deletion, we always go for linked list, right? Okay, and when you talk about an array, we'll always go when we really to less insertion deletion, more about accessing the element itself. Okay, right? Yeah. So you will go for array itself, because array we can directly we can access, but in a linked list, if you want to access, then you have to traverse. As a result, a lot of time is taken. And extra memory I was talking about, because you have the address to be stored into. And lastly is the no locality of reference. So having said this, linked list, as I was summing up, is a linear data structure. No contiguous memory location, right? Yes. So, and each of these node will be represented by two parts. One is the info of the data, another is the address of the next node, right? So if I'm storing a list of 10, 20, 30, right? 10, it will be represented by a node which will have the value data 10, and the address of whom, the next element, which is the 20. Yes, right? Yes, and the advantage of this particular linked list is that, yes, is that insertion and deletion we can easily do, because we simply we don't have to remove, even change the data itself. Okay, simply if you change the address itself, we can already do. So this will be clear when we are talking about creation and all these things, right? And the disadvantages, we cannot have the random access. Okay, extra memory is required and no locality of references. Right. So having said this, I hope you have got a clear concept of linked list. Do watch my video and keep subscribing.